Okay, so here's a video, and this circuit comes from lesson 20, question 15. But to make this work for you guys, and so you understand all the steps, I'm going to change the value of the resistors to, let's just say, 30 ohm resistors, and I'm going to change the voltage supply to, let's just make it 30 volts. Alright, and there's that mistake where there was a line across here, and I went ahead and deleted that line so you won't see that, and we discussed that in class that was a mistake. So, and I'm going to solve this using that one method where basically we lay this out like it's a straight line all the way across. Actually, give myself just a little bit more room on this. Alright, so I'm going to start off. I've got myself a negative, and it's going to come across here clockwise, and I've got 1, 2, 3 resistors in this inside loop. So that's going to be the base for my first line. So I'm going to come across. I'm going to come over just a little bit further. Do my next resistor, and then come further over and do my last resistor. So you can see coming across, I've got 1, 2, 3 resistors, which represent R1, R3, and R6. So I'm going to go ahead and name those. There's, I'll write it on right on top there, R1, R3, and R6, and they are all 30 ohms. Oops. Okay, now around resistor R3, I'm going to have 1, 2 more resistors. So I'm going to come across, I'm going to come up right here, and that's going to be the first one is going to be resistor R2 and then resistor R4. So right here, this be R2, this be R4, and they are both 30 ohms. And then finally, up here, around resistor R4, I've got one more, which is resistor R6, right? No, R5, sorry, resistor R5. So come up right here. And this is R5, and I'll write it on top there at 30 ohms. Okay, and I went ahead and made a table for this to see if we can get this to work out. So I know all of my resistors all the way across are all 30 ohms. So I'm going to write them in on this table. 30 ohms. And we don't know all of our individual voltages, but we do know that our total voltage is, I think I said 30 volts. Yeah, 30 volts. Okay. So these rules will still apply. As long as we know two things on each line, we'll be able to solve for the other unknown. So, to start reducing this guy, and basically with this method, we're going to have to drop this down to our flat line. So right here I'm going to have to reduce these two first in parallel. So I'm going to do what R5 and R4 in parallel. So I'm going to redraw like so. And that is R1 at 30, R3 at 30, R6 at 30. I'm going to have R2, and then we're going to have, so I'm going to call that R2 at 30. And then we're going to have a combination now of R4, 5. Now, being that these resistors are of equal value, I could simply take the value of one resistor divided by how many I have. So that would be, let's see, I'll just do it over here. R4, 5 is going to be equal to 30 ohms divided by 2, which is going to be 15 ohms. So that's what this guy is right here. Okay. Now our next step, before we get reduced down, is we're going to have to combine these two in series. Okay. So let me redraw again. This is still R1 at 30. This is still R3 at 30. And this is still R6 at 30. However, these two here are now going to be combined into one. In parallel with the R3. So it's going to be named R2, 4, 5, and we could simply just add these two values together, which is going to be 45 ohms. Okay? Next step is we're going to reduce this down one more step. I'm going to take this across. This is going to come parallel down, so now we're down to almost where it's just a straight line. This is still R1 at 30. This is still R6 at 30. But here, now this is going to be R2, 3, 4, 5. And there's a few different ways you could do this. Now, in my opinion, the easiest way is to use a variation of the equal resistor rule, since they're not too far away from each other. So a common number that this will go, 45 will go into, would be 90 twice. This will go into 90 3 times, right? 45 will go into it twice, 30 will go into it 3 times. I add these two numbers together, so I can just say 90 divided by 5, and that's going to be 18. So right down here, that value is 18 ohms. So now the final step, our final step in reducing this, is going to be R1 plus R2, 3, 4, 5 plus R6. So 30 plus 18 plus 30. And it would be drawn and it's going to be named R total now. So 30 and 30 be 60, so it's going to be 78. Okay? So now I can come up to the table. We'll write 78 ohms. And now we could use these two values to figure out our total current. Okay? So I'm going to take 30 volts divided by 78 ohms. So I'll come over here. So I total is going to be equal to E total divided by R total. So that's going to be 30 volts divided by 78 ohms. So 30 divided by 78, and it looks like it's what, 0.38 amps, 0.385. We'll just call it 0.385. That'll get us a little bit more accurate. So that's 0.385 amps. So I'm going to write that in right here. Okay. And now I can come back down to this, and being that this is representative of a series circuit above, that 0.385 amps is going to be my reference. So I could put it here, and here, and here. So I can go ahead and drop that into my chart for these two, since they're completed numbers. So I'm going to say I have 0.385 here and 0.385 there. And then also from that point, since I've got two complete numbers here, I could take and solve like so. I could say E1 is equal to I1 times R1, which is 0.385 times 30 ohms. So 0.385 times 30, that's going to be 11.55. So 11.55 volts. So I can come back to my chart.